Welcome to an introduction to Pulumi IaC with AWS in Python. So prerequisites, you need to have Pulumi installed. You need to have Python 3. So I think I have 3.13. Any Python 3 should work, I believe. You need to have access to an AWS account, and you need to sign up for a free Pulumi cloud account. So let's just go over infrastructure as code. Pulumi IaC has this tagline, your cloud, your language, your way. The thing that really resonates with me is this your language. So with Pulumi, you can write infrastructure as code using code, right? We're gonna be using Python today. You could use TypeScript, you could use JavaScript, any of the .NET options, including even VB script, but also F#. JVM, welcome. I'm a big fan of Scala. I like Kotlin as well. But yeah, certainly you can write Pulumi infrastructure as code in Java, Go. So many options, right? But like, why does that matter? To me, it matters because I like code, right? I'm very familiar with it. I like to be able to use the tooling that I get when I'm working in Python to write my infrastructure, right? So I like to use the type checking, the linting. I like that I can use my VS Code and I can get the autocomplete. I'll show some examples of this, that I can explore a package. I can go to definition, get some examples for how you might set up an S3 bucket. I like that, there's like parsing and type checking before I apply some sort of change to my cloud infrastructure. I like that I can have, my Python project and my infrastructure that it runs on in the same language using the same tooling, and I can understand it all. And the infrastructure isn't just this part that only I understand and the backend developers don't know what it is. It's all in the same language. To me, that's like a huge deal. So that's your language. Your cloud means that, you can see here in this diagram, we have support for a whole bunch of different clouds, right? We're going to be using AWS, but you could be doing things with Azure or Google Cloud. We have Kubernetes support, DigitalOcean, Hetzner, and so many others, and things that aren't even really clouds exactly, like, Elasticsearch Cloud or MongoDB's Cloud Atlas, I think it's called. Yes, lots of support for lots of type of cloud resources. So that's kind of the pitch for why you might want to use Pulumi. Here's just a quick comparison, because I think when I mentioned that, the next question is always, well, what about Terraform, or what about CloudFormation, etc. So this table kind of goes through that. You can see, Pulumi has a really good answer for secrets, which is important. But the big thing here is Pulumi lets you use a general purpose programming language, and it lets you work on any cloud, right? Terraform, you can use many clouds, but you can't use your programming language of choice. CDK, you can use a programming language, but it's AWS only. So Pulumi's kind of in that sweet spot of covering all these things. So let's go over just some base concepts. What is it saying? If the code link is coming up for you, I'm just reading the chat here. So using Pulumi is going to make a lot of sense if we cover some base concepts first. So in Pulumi, you have a project. A project is just basically a folder with a program in it. In this program, you will set up a number of resources, some cloud resources. Declaratively, today we're going to set up a Lambda. Those will have inputs and outputs. For instance, if you were setting up an EC2 instance, you might be declaring its size, or if you're setting up a cluster, you might have its scale or its min or max size. And then outputs are things after you set it up that you might get as an output, like it's Amazon ARN, for instance. So that is how you would describe your cloud infrastructure. And then when you instantiate that, when you create an instance of that, that is going to be a stack, right? So an instance of it running in your cloud. And with Pulumi, you can have multiple stacks. So here we have an example where we have a dev stack, a QA stack, and a prod stack. So it's all the same resources, but we have 3 copies of it. And you can make some changes, right? You may want, for instance, your prod stack to have a much larger Kubernetes size, or to use larger instances, and your dev stack is much smaller. But the important thing to know here is just your program describes these resources, and then when you create those in your cloud, you do that in a stack. And how that works, right? I'm sure if you've attended previous talks on infrastructure as code, you might understand this, but the way it works is I have my project down here, right? So I'm describing my resources in this main file. This is my program. And say I describe a number of resources, and then I go in and I add a new S3 bucket. When I run Pulumi up, the Pulumi engine is going to look at the resources I've declaratively described, compare them to the state file that's in Pulumi Cloud that describes like the current state of the world, and see that there's now something new, right? It's basically diffing these two, and then it's going to, because I've added something new, it's going to do a create on the Pulumi AWS provider. If I were to remove something, it would then remove it, right? And you can have multiple providers, so this can work, across multi-cloud. That's kind of the program, it's kind of like the runtime model, right? You're describing the end state of the world, and then it's making the changes that are needed. Okay, so let's do a demo. I think these concepts will make a lot more sense when we see some code. So let's close this. Everybody hopefully can see my VS Code. So I have this folder, and we are going to create some infrastructure. So the first step is going to be to do a Pulumi new. I'm going to put a force flag here for reasons you'll see shortly. And then you get a couple options. You can choose a template, or you can choose from AI. With the AI, you kind of describe what you're looking for, but we're just going to do a template, and we're going to do AWS Python. And then we will choose a project name. We can give it a description, and we can choose our default stack. I'm going to use dev. And then for Python, you can choose your tool chain, basically what you're using for packaging. I'm going to use pip. I do recommend UV actually for a more long-term project, but pip is great for a demo. So I'm going to choose to run this in CA Central 1, go Canada. Yeah, UV, if you haven't used it, if you're a Python person, super fast, super nice, a lot of great defaults built in. Totally recommend it. But pip is like the familiar tool that everybody knows. Okay, so once we run that, here's what we're going to get. I actually had a couple files here already that we'll go over shortly. But first of all, we get our Pulumi YAML file. Here's our name and description we filled out, Python pip, and you can see it set up a VM. Here's our stack. We're not going to deal with this too much, but there's our region. It set up a VM, a virtual environment for Python with our packages in here. And then it set up this main file. It's interesting that I'm getting a squiggle there. Might need to activate my virtual environment.
If this does not work, just close and reopen the browser from a sourced CLI point. I struggle with this as well.
I think might need to source VM bin activate. What was your recommendation? Just restart it?
Yeah, see, I would quit VS Code, and then this is, by the way, folks, this is a problem that is, as far as I know, mostly limited to demos. I do not generally have this issue when I am, so then start it from a new, I think if you really just, even if you just open it, it will probably pick it up.
That's awesome. Yeah, interesting, because I did a run through and that did not happen. That's fun. Okay, so this was our default template, right? It's just creating a bucket and then exporting the name. The way we would run this, right, is I'm going to do Pulumi up. Pulumi up, it has some nice UI around it, but it's basically going to ask us if we want to run this program and apply these changes where it's going to create a new bucket, right? We can go in and see details here. You can see the bucket has this funky name on the end. Then let's run it. You may or may not know, right? S3 buckets, it's like a global namespace that everyone shares. So my bucket, you know, as a bucket name won't actually work, but thankfully Pulumi has a resource naming auto mangling feature that I have turned on here by not specifying a specific name, and it's added this on the end. Okay, so we've created that bucket. Let's make some more changes. Just look at my demo code over to the side here. Because I was mentioning before, the thing that I like about Pulumi is that it's just code, right? And just to show that, I'm just going to show you that I can just read in a file and use that file content in my program. I think that this should be this. I think that my Copilot is getting a little eager here, but what I want to say is content is f.read. So because this is just Python code, right, I can just read a file in the middle of it. I'm going to create that file. There are actually better ways to get a text file into an S3 bucket, but I just like the idea that this is just a string and I can just pass it as the next stage into my infrastructure as code, because maybe it's not just opening a file, right? Maybe what I need to do is call some obscure thing or put together a complicated string. And the beautiful thing with Python is I can just do that using the language I know well. And then like as I put together my infrastructure here, I get this nice autocomplete feature, right? Which I just love, because this is how I'm used to working. And I know that I have this bucket up here, and then I can get its ID. And I just like programming languages. Did I mention that? And then I could pass in my string, like so. And so now, if I run Pulumi up again, it's going to see that we have a new change, right? It should see that we have this new text file. I'm going to hit yes and apply that. And boom, now we have put my file into an S3 bucket. The way that I can verify that, right? I can use this Pulumi stack output name to get the bucket name. And then, let's see here. Just to, oops, am I copying the wrong code? What I can show you is that if I use the AWS S3 copy tool, I can pass in this Pulumi bucket name in the middle and just show you that that file is actually there. But this is super handy, right? Being able to use these stack names in my scripting. Okay, but that's easy. That's just setting up an S3 bucket and putting some value in it. Let's move on to doing stuff with lambdas, right? So what I want to show you and help you set up is this. So we're going to take a Flask app and we're going to have it read the text file. Instead, we're going to put that text file into a Docker container. We're going to take that Docker image, push it to ECR, the container repository of AWS. And then we're going to hook that up to a Lambda. We're going to hook that Lambda up to an API gateway so that whatever our Python Flask program is, we get a web accessible endpoint for it. So here's my Flask program. This is just standard Python, micro web framework. And it has one route that's just going to grab our file and return it. To make it work in a Lambda, we have this Lambda handler, which just makes it listen on this AWS gateway interface. It's just a different format. Yeah, so we need to add these to our requirements file. Make this all work. So that was Flask. That was AWS. What was it? So it's AWS website gateway interface. And then I'm going to add also, because I know that I need this, the Pulumi AWSX. Then we'll do pip install requirements. So it's some interesting things about code organization here, right? This is my infrastructure code. This is my app. Now, in a real world use case, maybe I wouldn't want them in the same folder, but it's nice to keep them nearby when they have to, when one refers to the other. There's actually a lot of different schools on this, right? Some people like to have a poly repo setup where every service has its own repository. And then maybe in your organization, there is a repo that does certain base infrastructure stuff. And then you have a bunch of web services, and each one maybe has a folder that sets up infrastructure, sets up Kubernetes, does any of the kind of infrastructure-y stuff, and lives side by side with the project. Maybe you have a monorepo setup where all the code is in one giant service, but still I think it makes sense to keep related infrastructure close to the code. In this case, right, just for this demo, I have these actually in the same exact folder. Probably not ideal long-term. I might want to separate these out, but works great for a demo. Okay, so this is my Flask file. I'm going to put it into this Docker file. No, I don't need help using the Docker language. So my Docker file is pretty simple. I'm going to copy in that app file. I'm going to copy in my text file and my requirements file, and I'm just going to run this pip install. The one special thing for Lambda, right, is instead of just starting up the Flask app as normal, I'm telling it to use this Lambda handler. And I'm using AWS's Lambda base image. You can actually not use their base image, but it's just easier to do so unless you have some reason, like some golden image you guys use internally. Then it can be done, but there's a little bit more setup. Okay, so that is our app that we'd like to get running. Let's go back to the infrastructure. I'm actually going to start copying and pasting stuff, because I think that'll be a little easier. So we're going to add a couple more imports. And then we're going to set up a Lambda. Like this. I'm going to walk through what we are doing. Okay. Where are we here? So, as I mentioned in this diagram, actually, this is a more detailed diagram. So we're going to set up a Lambda. We need to set up some security, a role and a policy for that. We need to build a Docker image and set up this repository that we push it to. And then we need to link these two so that this Lambda, hopefully this is big enough, so that this Lambda uses this image from this repository, right? So what's level I'm at? Yeah, that works. Okay, so first step is to set up an ECR repository. We're going to set force delete equals true, because that just makes it easier to tear down afterwards. We're going to turn image scanning on, so it's going to find vulnerabilities. Then we're going to set up an image. So this comes from this AWSX module. Lets us build an image, tag it, and then push it. So it's quite convenient. So we're going to take as an input for our image this repository URL that we set up here. So if you're familiar with Docker containers, right? First, we have the Docker file. We're going to build in the local context. And then afterwards, we're going to tag it to be part of this repository URL and then push it. The platform I'm setting as AMD 64. As I put here in my comment, that's because I'm on a Mac, which is ARM, and Docker images are platform specific, right? So my Lambda is going to be x86, so I need to make sure I build it that way. Then I'm going to set up some permissions. So here I am actually using this JSON dumps feature from Python that makes it very easy, right, to take an object and turn it into JSON. So this is just another example, although I copy pasted it, we're using the features of Python to just make it a little bit easier to write this type of code. Then we're going to set up a policy. We give it the Lambda name. So this is the output from our previous step that we're applying here as an input. And so that should give us a Lambda. Let's add here some outputs. So we're going to add some outputs. Doesn't like that. Lambda function is not defined. Oh, we didn't actually set up the Lambda yet. Well, let's do that. So yeah, our last step, of course, is the Lambda. So we set up the Lambda. I'm calling it custom Lambda. Package type image. You can, of course, set up Lambdas that take a zip file, right? I just like using container image because it works the same locally. I can set it up. I can play around with it. I can install, like operating system level packages. Super handy. Timeout, 30 seconds. Memory size, 512. Here's the important part. We are setting it again to be x86 so that it matches our container. And then I'm just telling it Flask is in production mode, passing that through. So let's run that. So we should be able to see here that it's seeing all the new things, doing that diffing that we talked about. Run yes. And it's going to need to build this image. It's going to try to do things as in parallel as it can, right? It's set all these up at once. The image is kind of our most expensive operation, and the function depends upon that because we're going to, we set right here as the image, the image URI. So basically the hash of the image. And to get that hash, we have to build the whole image. So we can actually see this in Pulumi Cloud. Well, that scroll might not be working for me. There we go. So we can see here the ECR repo is set up here. This is our image name. So it's been tagged with this repo. And then we're just using the SHA of it. And then here's our Lambda ARN. We could, of course, deal with this container outside of our Pulumi code, right? Instead of building the image here, we could do Docker. It could be Docker build dot, and then Docker tag, and then Docker push. But it's nice having it all together. And so if we go into AWS, let's see, Lambda. So we have this Lambda. This should be it. E59. Yeah. So that's our Lambda. So we've now set up kind of all of this part, right? We've set up our Lambda. We've set up the security. We have our Docker image. We have our ECR repo. Now we want to make it callable. So we're actually going to set up the API gateway and the permissions around that. Oops. Let's see, is there anything I didn't cover here? I think that's good. So now let's do API gateway. Yeah, so now we're going to set up API gateway using API gateway v2. So you may be familiar, there are two versions of API gateway. V1 is the REST one, I believe, and V2 is HTTP. The HTTP one is cheaper and it does less, and it works just great for what I'm going to be doing here. Basically, we're just going to push through the request all the way down to our container so that Flask can actually do the routing. I believe this is called the fat lambda pattern. And it's pretty convenient in certain use cases. So we set up this API gateway, then we're going to set up an integration, right? Our integration is what's going to wire it to Lambda, and the integration type is AWS proxy. The integration method is post, and what is it going to post against? It's going to post against our Lambda functions ARN, which we can see, right here. Then we need to set up the routing, right? So there's lots of ways that you can do this with the API gateway. A common pattern, right, might be that you have a whole bunch of Lambdas, and they each do like one small thing, and you push different routes to different Lambdas. What I'm doing here is the opposite. I have a container with a whole Flask app. I can put as many routes as I want in that, and we're going to proxy the whole thing through, which can be pretty convenient if you're used to, working in something like Flask where you can just spin up routes in Python code. You do have to set up a stage to make this all work. This is just a default stage. And then we need some permissions. So allow API gateway. Yeah, so we basically need to set a permission that our API gateway can actually call our Lambda. And so that is the permission here. We give it the function name, and then we're passing in the ARN here using these nice F strings to tell it can call anything on there. And that's kind of it. So let's see what happens. So we'll do a Pulumi up again. And it should, see, it's okay. We have a new API, we have a new stage. Our image is changed. We need to update that. And then that causes our Lambda to update. And then we're going to have the route and the integration and the permissions. So number of changes. We can go into details and see those in detail. You can see how, because of how I'm doing this image tagging, the URI is changing every build, which is actually pretty convenient for what I'm doing here. So let's apply those. We can go actually and see this in Pulumi Cloud. So you go to app.pulumi.com. You can see these changes being rolled out. And a lot of these concepts we've been going over are exposed very well, right? We have a stack. This is my project, AWS intro. We're in the dev stack, and I can see the updates coming through. Here's my overview. You can see the various changes, updates. And that went pretty fast. The way I sometimes think about it is like Pulumi is like Git, and Pulumi Cloud is like GitHub, right? So Git lets you do the basic actions, but if I want to come in here and see who's making changes, want to work together and collaborate, want to do CI/CD stuff, it's a great place for it. Okay, so that rolled out, and you know what we didn't add is we actually needed to output what our URL is. It's actually pretty important for the demo. So let's do that one more time. So because we need to get the API endpoint so that I can show you that this actually works. So I'm going to do a yes here. We'll see that roll out. And we should be able to see if we go into AWS. So there's our Lambda. But if we go home, go to API Gateway, we should be able to see the stuff we're setting up. Which one is it? So here we can see the proxy that we set up. So any endpoint gets proxied through. Here's our integration, where that gets proxied through to call our AWS Lambda. Here's the stage that we had to set up. What else do we have to set up? I think those are the main things. But you could expand this to add a domain name on this, for instance. Let's see. So that worked. And here's our API URL. And here's the drum roll moment. Boom. So now we are returning that text file via a Lambda. So if we go back to this diagram, let's see. Actually, let's start with the simple one. So here's what we've done, right? We've taken kind of something that works quite well locally, just having a Flask app. We've packaged that up with the text file in the Docker container, right? We have pushed that to ECR, and then that's running in our Lambda image, as we can see here. Now you may actually notice that we're not using our S3 bucket at all. We could change things to use the S3 bucket. So rather than packaging up that text file, put it in an S3 bucket, and then it would be easier to make changes to it. But actually, for our purposes today, let's remove it and to detect that change. Skipping preview. Oh, what happened? Oh, see this? The beauty of a programming language telling me when I've made a mistake. I can no longer output this because it no longer exists. So we're going to apply that change. And then we'll have our Lambda set up. And the thing I like about this setup for Lambdas is, it's very easy to add a new route to this endpoint, right? I wonder if Copilot will help me here. If I do app.route JSON. So if I add this, just returning some default JSON code to the endpoint, I actually don't have to make any changes to my Lambda because I've routed everything through. So the reason I like this is because locally I can just work on this as need be, right? I can even start up the container locally if I'd like. And then all I have to do is run Pulumi up and make changes to that, which is pretty nice. So that worked here. Perfect. But like I should say, the point of this is actually not the Lambda or the Flask code, right? The thing that is important to me is that they're in the same language and I can understand them both, right? Like I don't need to switch the tool set that I'm using to switch between working on my app, which is here, right? And working on my infrastructure, which is here. I mean, maybe in the real world, I will not have them side by side. They'll probably be in a separate folder. They probably won't share the same requirements, .txt file, but it's super nice that the same skill set that I use in one place can work in the other. That way it's not just like, oh, only Todd, or only that team knows how to do this infrastructure stuff, because it's different than how we do our back-end programming or our front-end programming. Having it all together, having it use the same tool set, being able to use the like linters and type checkers. Usually when I write Python, I use types. I use the type checker. I use rough and I use MyPy, eliminate duplicate code. I have a whole tool set I like to use to keep everything nice and clean and together. And I love that I can use those same skills, use that same skill set with my infrastructure. Everything's kind of all the same. So that is kind of the big deal here. Not necessarily setting up a Lambda in Flask, but that you can do that. Main. So we could expand on this, right? We could add pulling things from S3. I could show you how to set up different stacks. We could actually take out our image, for instance, and start pushing things manually. Then we would need to switch our value here to be our tagged string. Like maybe we would have like whatever blah.latest we would use here. You can change the Lambda so that it receives a message from the event bus whenever you push something to the repo, and then it will auto update based on your container. Lots that can be done here, but I think this is a great place to get started with using Python and infrastructure as code. You also might notice, right, there's just a lot of details here. Like there's a lot to get a Lambda in place and hooked up this way. But the beautiful thing about code, right, is it's easy to abstract that. If I worked at an organization and we were repeating this pattern, right, it's easy to take all of this, just put it in a Python function, pass in the couple of things needed, like what app we're wrapping up, put that in a package, right? And then other people in the organization can pull in that package and they can use that to set up their services into Lambdas. And then if we need to make a change, if we're like, okay, we actually want to do things this way or that way, we want to change the API gateway to be the V1, or we want to put a load balancer or do whatever, like all that code is in a common place and you just need to change it once and then all the people just can update their package and so on and so forth. All they really need to worry about is describing, you know, the high level, and you, the infrastructure expert, can, you know, package that up. That is pretty exciting to me. All right, so that, I think, is the demo. Let me look at my list here, make sure we covered everything. I think so, right? I've shown you it in Pulumi Cloud. I've shown you how this works in AWS. All right, so let's go back to my slides. All right, so that was the demo. The link to the code is here. I think Josh fixed my broken link. If you want to check that out. There is actually also a blog post that kind of relates to this topic, covers some of the same code, but goes over when you might actually want to use a Lambda as opposed to running, you know, a container in a more, you know, standard AWS way, like, you know, in Fargate, for instance. It's great. Lambdas like this are great if you have something that needs to be up but doesn't receive a ton of traffic. It can be like very cost efficient to have something that gets, you know, less than 1 million requests a month just sitting in a Lambda, because if you can afford that slow cold upstart time, it can be quite cost efficient. That's the only downside. I guess I didn't mention that. When the Lambda starts up, you know, there can be some delay. With Python, it's actually not too bad. With some other languages, like I said, I love Scala. Scala can be quite slow to start up in a Lambda. There's some ways to get around that though. But yeah, check those out. Let's answer some Pulumi common questions. First of all, today I used the Pulumi AWS package and the AWS X package. But let's go back to my screen share. Let's go Pulumi registry. There's actually a ton of packages, right? So these are the big ones, but we used another one today, this Pulumi crosswalk, and everything's there, right? That you need to build your own resources in the cloud. Common questions that we often get: how can I migrate to Pulumi? So it depends where you're coming from, right? If you're coming from Terraform, there are some ways to convert that code. If you're coming from just having manually set things up, then yeah, you can do an import. But the best thing to do is join our Slack channel and ask some questions. There's a lot of people there who've done it before. What is Pulumi Cloud? So I think I mentioned where you can think of the Pulumi packages that we were using as something like Git. Pulumi Cloud is like GitHub. It is a commercial product. It will store your state file. It will take care of secrets, but it does a lot more. You know, it lets you collaborate as a team. It lets you see who's pushing out changes, what changes happened, when. So you can set up a free account, and if you're not using it like in a corporate context, it's not going to cost you anything. As you get to larger teams and more resources, you know, there's pricing involved, of course. Pulumi Cloud is super helpful. Fun links that you might want to check out. I already mentioned the registry. This Pulumi concepts page is also fantastic. Goes through some of the concepts we covered. and some others that I haven't covered in much more detail. Coffee sip break here. One thing that we haven't covered is stack references, which are super handy. You may work in an organization where like there's some base infrastructure being set up in infrastructure as code, and then you can use a stack reference to refer to that within your existing projects. So you can kind of have a layered effect and have some abstractions. So take a look at that. Yeah, let's go to some questions, if there are any.
Oh, there are questions. Questions for days.
Questions for days. How do I work the question thing?
Oh, so yeah. So the way it works is you go to the Q&A tab, and then you pick a question that you like, and then you click max. Now, pardon, please excuse this audience as I have to explain this because I make this mistake every time. When you maximize a question and put it on the screen, you have to remember to click the X if you go back to sharing your screen to show where the answer is in the docs, or to show like to show your code editor, because I always screw that up, and someone from the audience always says, "Hey, you forgot to close the question." So
perfect. Okay, so so I hit max. If somebody already has infrastructure set up and they want to shift to Pulumi to incorporate that, is that possible? It looks like Josh has already answered this, that you can do a conversion.
yeah, I'm happy to chime in here. So
Yeah.
Terraform is probably the most common place that we see our customers coming from. Essentially, the story with Terraform is you can do a lot of different things. You can reference an existing state file. I did not actually mention that in my written answer. You can also automatically convert Terraform code to any Pulumi language. And then you can also import the state file. And then if your infrastructure is managed by CloudFormation, you can reference a CloudFormation stack output if you want to build on top of it. And if you want to, and if you want to, you can also import any. You can also, there's a Pulumi import command, so you can import any piece of existing resource. If you just want to grab a piece of existing resource within a Pulumi program and you already know its ID, for example, every Pulumi resource in the registry has what's called a get function. So like, for example, for a VPC, you just you give it a name for within your Pulumi program. You give it the ID. Pulumi will grab it at execution time, and then you can look at its properties. So, for example, you might want to take an existing VPC and then add a security group to it, and you already know the VPC's ID. You can also stick that ID in your configuration to make your code, reusable. And then you can grab that VPC and then look at, for example, its CIDR block if you're trying to set up a security group.
That is an awesome and comprehensive answer. We have a related question here, Josh, which is I set things up manually.
Great question. So, as someone who we've both had to learn IaC, right? We weren't. We did not enter this existence knowing IaC. Should you first set up things manually and then automate it using Pulumi? Oftentimes that's a good way to do it. Sometimes I'm actually able to learn how services work by actually writing the IaC first. So it's kind of either way. Some things are easier to learn by like just spinning it up in the console and playing with it. So I would say, for example, like a VPC, for example, if you want to put something in a VPC, then create that, and you don't know anything about VPCs, create it using the AWS console, then learn how to do it with Pulumi. And by the way, Pulumi has a component that allows you to create VPCs with a single line of code that kind of incorporates all the best practices. So that's also worth knowing. That's, by the way, in the AWS X package. So I think that I think creating things in the console is definitely a valid way to learn things, and it kind of depends on a case by case basis whether that's the best way to learn things. But I would actually try to, as the most generic advice I could give, I would say try poking at it from both ways. I would say try IaC first, and if you're really, really confused, then maybe just spin it up in the console to get an idea of how the various resources interact. Because very rarely, when you're trying to do anything in cloud, there is usually a number of resources that you actually need to create in order to do something useful. So yes, this is a very long answer, but I think that I would actually say both. Try both, poke at it both ways, and you'll eventually get there.
Yeah, and I would say some things are a lot easier in code. I mean, you were mentioning that and Pulumi AI exists, and Pulumi Copilot, where you can ask it questions about setting things up.
Yes, that is also important. In fact, Adam, if you want to do there you go.
Yeah.
So this is Pulumi AI. Basically, the way it works is you enter a general language or a English language prompt, and then Pulumi will output a Pulumi program in whatever language you select, and it's all of the Pulumi supported languages. Being an LLM, it is not going to be perfect. The more common the problem that you're trying to show, the more reliable the answer would be, but it's usually going to be pretty close, and will at least get you some useful output the overwhelming majority of the time.
And so the example I showed today, actually setting up the API gateway to go to a Lambda in AWS is super hard. Like, I never found it very easy. I actually did it by starting with something like this and then making changes in the code until it worked, because I don't know, I found the console here pretty confusing to actually get it to proxy through the routes and to get the permissions right. So that was a case where I found the code like way easier with a little help from an LLM that was like, it was pretty close to right on some of the parts, and some of the parts it wasn't. All right, do we have other questions? Oh yeah, here's one. What's the difference between AWS and AWS X libraries? So the AWS X one, you can find it here. Crosswalk. So I believe it just has some higher level concepts. It is the answer. I don't think I'm sharing my screen, am I? I was just switching to show it, but
another presenter bitten by the bug.
That's funny. Yeah, so AWS X, Josh, when you say it's like higher level concepts to try to let you build things with larger, bigger building blocks.
Yeah, exactly. AWS X is essentially like a component library that incorporates. Yeah, it is basically component focused. There's other libraries in the AWS universe. We have an EKS library that is AWS X is kind of like the generic one, and you mostly use it for the VPC component. And then there's also an EKS library. And there's a couple others, but AWS X and the EKS ones are the ones that I use the most frequently.
Somebody, let's see here. Yes, there will be a recording provided, and the slides are actually already linked, but yeah, those will be provided as well. There's a question, how does Pulumi reduce costs? I mean, one way is a tool that we didn't even cover here, which is Pulumi Insights. With Pulumi Insights, I mean, you don't need to do any sort of infrastructure as code things. You can just have things you set up manually. You go into Pulumi Cloud, you connect it to your cloud account, and it will suck all that in. It can work across multiple clouds, and it can show you what you have going on. And you can also use Pulumi Copilot to ask questions. But it's super handy because you can just say like, hey, what's expensive that's running right now? It actually doesn't have cost data, but it will know that like this extra large instance is actually probably pretty expensive. And yeah, I found like an EKS cluster that was running, that somebody left running that way. So that is a great way to cut costs, is to just know what you have. So Insights is great for that. We're running out of time. Let's go back to the slides. So if you enjoyed this talk, if you're still here, you should definitely check out Pulumi Up, where you can discover best practices and lessons learned. And there's also customer stories, which I think is like super interesting. So follow this link. It is on May 6th and 7th, depending on your time zone, and a lot of amazing talks happening there. So I would definitely check it out. Excuse me. To continue your Pulumi journey, go to this slack.pulumi.com, join the Slack. That's a great place. You know, like there's more questions here than we probably have a chance to answer. But if you join the Slack, I'm on there. Josh is on there, who I would recommend over me in almost all cases. Unless you have questions about Canada, then I'm here to help. But yeah, both of us are there. Ask questions. Sign up for a Pulumi cloud account and try it out. Yeah, and thanks for coming to the workshop. Let's see. Yeah, so again, Adam Gordon Bell, community engineer, birthday boy. And this is my email if you want to reach out to me, but probably the Slack is a better place. I think that's all for the workshop. Anything else we should cover, Josh?
Sorry, I'm answering one last question here. That is a good one. So we actually have a question about like, what are the equivalents of data sources in the providers? Let's maximize this one. Yeah. So, so in Terraform, for those that aren't familiar, there are these things called data sources. They are essentially queries. They will either return one result. If they can't find it, they will produce an error, or they will try to return multiple results. All of those things are mapped in the AWS provider. And so if you go to the Pulumi registry, Adam, would you be able to bring that up? Just navigate to the Pulumi registry for the AWS provider. Those, so the Pulumi AWS provider takes the Terraform provider as a dependency, right? We have our own engine. We do not use the Terraform.
Which provider?
Engine.
Sorry?
The AWS provider.
Oh, yeah.
And then if you just go to like the EC2 namespace.
EC2.
Yeah. So the M on that blue, it might be a little hard to see, but that green M, that is a module. And then within each module is just a namespace. And then within each of that, we have resources, which you see here. But Adam, if you scroll down, you will see the list of, scroll up just a little bit. You'll see functions, get AMI IDs, right? Those are mapped from the data sources in the upstream Terraform provider. So all of that functionality is also there in the Pulumi AWS provider, in addition to that static get method that is on every single resource. So the data sources map as what are called in Pulumi functions, and the resources map as resources.
All right, shall we call it then?
We shall.
All right, thank you, everybody. Please check out another workshop. There's more coming.
So long, everybody. Thanks for spending time with us.